Organizing data, section 2.2, bar graphs, circle graphs, and time series graphs. This is simply a survey of various ways of organizing data. So, determine types of graphs appropriate for specific data. Construct bar graphs, Pareto charts, circle graphs, time series graphs, and interpret information displayed in graphs. So these are the focus points of this particular lesson. Histograms provide a useful visual display of the distribution of data. However, the data must be quantitative. Quantitative means numeric, right? In this section, we examine other ways of graphs, uh, other types of graphs, some of which are suitable for qualitative or category data as well. So that's what we want to study in this section, graphs which will represent qualitative data. Let's start with bar graphs. These are graphs that can be used to display quantitative or qualitative data. So bars can be vertical or horizontal. Are of uniform width and uniformly spaced. Lengths of the bars represent values of the variable being displayed, frequency of occurrence or the percentage of occurrence. The same measurement scale is used for the length of each bar. Graph is well annotated with title, labels, and vertical scale. Okay, here are examples. So if you're looking at life expectancy, so that's your frequency of in age, right? So, and these are the years of birth, right? So years of birth, this is life expectancy. So different ages, you see, the blue one is for men, purple one is for women. All right. So you can notice that there is a, this looks taller than this. All you have done is, instead of going from 0, 20, 40, 60, 80, they have pushed that vertical scale a little bit to start from 65 onwards. Okay, so it's essentially the same graph, but once you change the scale, it looks slightly different. Okay, the graphs are called clustered bar graphs because there are two bars for each year of birth. So clustered bar graph. So notice there are two bar graphs. So one bar represents life expectancy for men, the other represents life expectancy for women. Height of each bar represents the life expectancy in years. An important feature illustrated is that of a changing scale. Notice the change of scale between 0 and 65 is compressed. The changing scale amplifies the apparent difference between lifespans for men and women, as well as the increase in lifespans, those born between 1980. So you see changing scale. Whenever you use a scale in a change in scale, warn the viewer by using a squiggle. That's a squiggle on the changed axis. Sometimes if a single bar is unusually long, the bar length is compressed with a squiggle in the bar itself. So let me explain again. You see this squiggle? Instead of going evenly 0, 20, 40, 60, 80, you squiggled the first 60 years, essentially 65 years, compress the vertical line. So this difference looks way more now because the scale has been changed. Okay, so be mindful of the change in scale and how that would result in the visual depiction of your data. All right, changing scale. Now, Pareto chart is a bar graph in which the bar height represents frequency of an event. In addition, the bars are arranged from left to right according to decreasing height. So an order is important. In Pareto, you start with the highest frequency and then go down. All right. So another popular pictorial representation is the circle graph or the pie chart. It is a relatively safe. It is relatively safe from misinterpretation and is especially useful for showing the division of a total quantity into its component parts. So you have probably seen circle graph or pie charts. All right. The total quantity is 100% is represented by the entire circle. Each wedge of the circle represents a component. All right. These proportional segments are usually labeled with corresponding percentages. In a circle graph or pie charts, wedges of circle usually display proportional parts of the total population. Let's see some example, right? Um, Pie charts. Here, that's an example of pie chart. So you're looking at something like this. In all, it should be 100%, and then each wedge has a certain percentage. Look at that. That other has been mapped to another circle which has its own wedges. Okay. So these so I hope this is clear. This is an example of circle chart, circle graph, or a pie chart. All right. So next video will cover the rest of the slide here. We are continuing on section 2.2. Until then.